This is the HO scale Marengo, Milwaukee, and Northern. Right now it exists only in the mind of Wayne Wesolowski. Perhaps you have a layout that exists only in your mind. How do you get past the hurdles so your dream becomes reality? How do you solve the problems of bench work, track, scenery, and cars? We hope to help with the basics of model railroading, presented by Model Railroader magazine. Wayne doesn't seem too interested in building a layout today. Perhaps he just needs some coaxing and good advice.
Sure like to get started on that layout for the boys today, but it's so comfortable. And the ball game's going to be on in a couple minutes. And there's all that bench work and track work and scenery and cars.
Sounds like you could use some help. Come on, Wayne. It's not all that bad. You know building a layout is really easy if you just take it step by step.
Who are you?
I'm your good sense. I'm here to motivate you to get started. Anyone can build a basic model railroad with simple tools and a minimum of expense. Remember, though, for a beginning layout, keep it simple, take plenty of time, and have fun.
Yeah, okay.
Hi, Wayne. What are you doing?
Well, hi, Alan. I'm just doing a little planning for this basic model railroad that I'd like to build. You know, I'd really like to jump in and get started right away, but something tells me I should be a little careful and do some planning first.
That's right, Wayne. You can save a lot of frustration and prevent mistakes if you just take the time to plan a little.
There are a lot of choices to be made. The first is era. That's perhaps the most general, but it will determine the type of railroad that we have. Railroads have existed since the early 1800s, but for me, I think I'll pick something about 1950 when I was a boy. You don't have to lock yourself into any one of these time periods. For you, steam might have lasted a decade longer, or perhaps your railroad never had passenger service at all. But it might be a little difficult to justify a wood-burning locomotive next to a GP50.
Unless, of course, it's an old-time fan trip passing through.
Oh, you got me, Alan. You know, Alan, you ought to study the history of these eras in these magazines and books. Once we've established the time frame, then it's necessary to look at the scope, the style, the economic status, and the type of railroad that you will be modeling. It could be mainline railroading, the high iron, 4-track, manicured right-of-way, crack passenger and express trains. Or we could take a completely different approach and model a simple backwoods 1-track branch line. Probably the smallest railroads are the industrial or connecting lines that only go for a mile or two. Some modelers can spend their entire career trying to capture every detail of the railroad scene. So we can model everything from a transcontinental line to a 1 or 2 mile short line. The next element is the financial status, which can range all the way from prosperity to near bankruptcy. This will affect track maintenance, car repair, and the general appearance of the railroad. You know, no modeler really has enough space to model every aspect of even a moderate-sized railroad. So many modelers choose to find 1 or 2 areas of specialization. If coal or heavy ore mining is the specialty, you need strong locomotives and many hoppers, gondolas, and ore cars. Trains would need helpers because of the weight. Another possibility would be a logging operation with plenty of opportunity for adding character to the scene. Alan, the possibilities are almost endless, but it really would be wise to limit ourselves to 1 or 2 specialties. At this point, we should be developing a pretty good picture of the sort of railroad we're modeling, and the geography should tie it all together. Since scenery will be a major part of the layout, pick something you're familiar with, an area where you vacationed, a place where you grew up, or just a place you dream about. Scale is another factor to consider. If you love the grandeur of the mountains and long trains, one of the smaller scales is for you. But if you like models with every nut and bolt of detail on them, then a larger scale, even in a small space, is what you want. There are 3 popular scales or sizes. O scale. It's the largest, has excellent running properties and great detail, though it's expensive, and it needs large radius curves. HO scale. It's the most popular and is a nice compromise between the small size and detailability. Everything is available commercially. N-scale. It's the smallest of the popular sizes and has a growing following. There's a good deal of commercial products, and it allows you to have the most track in a small space. Others include S, Z, Q, and G, and probably some others I haven't even heard about. Alan, among the last aspects we have to consider is how much of the layout we're going to build and how much we're going to buy. Some modelers scratch build almost everything for their layouts, while others purchase everything commercially. I think most layouts, though, fall someplace in between, with a majority of commercially purchased parts and kits and one or two kit-bashed or scratch-built highlights. You know, I think I'm going to save a place over here for that special structure I'd like to do someday. Okay, Alan, for my new railroad, I think I'll have something in the 1950s so we can have both steam and diesel. It'll be a well-kept branch line specializing in light industry. It'll feature Midwest terrain in HO scale since we only have a small space, 4.5 feet by 3 feet 8 inches. I'd like to do some operating and see the trains move rather than super detail a small scene. We'll use ready-to-run parts and equipment. We'll call it the Marengo, Milwaukee, and Northern. I can almost feel it coming to life already. There are hundreds of track plans to pick from in these Kalmbach books, or you could devise your own plan. Alan, the key to good bench work is that it be strong yet lightweight, and it should provide a rock-hard foundation for the track. It should be easy to assemble, disassemble, and modify whenever you need to. But that doesn't mean you need 4x4 legs and 2x12 stringers. Just look. If you take a dollar bill and attempt to support a silver dollar, it falls right through. While if I take the same dollar and pleat it, it will support the silver dollar. The angular construction, or the corrugation, adds tremendous strength without increasing the weight. This piece of wood is very flexible. If I add a small strip of wood on top, the new structure becomes very rigid. This kind of construction is called an L girder, and it will form the basis of our benchwork. Here's a little model using L girder construction. We have an L girder here, an L girder here, legs, and cross braces. Alan, would you give me that weight, please? This benchwork, even though it only weighs 3/4 of an ounce, can easily support this 12-pound weight. Okay, Alan, let's get started on some full-size benchwork. What we'll need for our L girders are a 1x4 and a 1x2 that are glued and screwed together. A C-clamp could be used to hold the pieces in place until the glue sets. I'll run a little glue along the top of this one. And Alan, would you help screwing in the top piece? We're using number 8, 1 1/4 inch flathead wood screws. When the joint is dry, we'll remove the screws and just let the glue hold it. Later, we might want to cut into the girder, and running into a hidden screw could be a disaster for our saw blade. You'll also need 2 sets of legs like these. 2x2s in the corner screwed to a 1x3 keeper joist. The legs are normally set about 1/5 of the way in from the edge. The height of the legs is also adjustable. Some people like to keep it rather short, about 36 inches. I think that gives an unnatural aerial view. It also makes it difficult to do wiring underneath. Some people like an eye or a head-high platform. That's more natural, but you'll need a step or a platform for short people and children. It is much easier, though, to get underneath and work on wiring. We'll compromise with a table that's about 42 inches high. Also, the higher the layout, the more lights you'll need. However, they have to be a lower wattage than on a shorter layout. Here, fewer lights with higher wattage can cover more layout space. It's a good idea to make the spacing between the lights about equal to the distance between the layout table and the lights themselves. You know, Alan, it's a good idea to finish the walls and ceiling of the layout room before the layout is built. It's just too hard crawling over the layout to put up wallboard and ceiling tile. Let's add the last 1x2 cross brace. We'll mark the 1x2. Then I'll cut it with a saw. Then reposition the brace and drill 2 holes, countersink them. Screw in one end with 2 screws. Measure the space between the legs so we keep everything square. Drill another hole and put in the final screw. And here's our finished leg assembly. I'll put a T-nut and a bolt into the holes in each of the legs. We'll see why later. Now here's the finished benchwork. We have the legs, the L girders, joists, a center joist that we've attached by screwing in from the bottom, and 1x1 cleats that will be used to attach the plywood top. Before we attach the top, we need to be sure that the benchwork is perfectly level. Even the best basements and other rooms don't have perfectly level floors. Here, Alan, you handle the level.
It's a little low on your end, Wayne.
Okay. How's that?
A little better.
More?
Yeah.
Okay. How about now?
Okay, that's good. The benchwork's level and we're ready for the top now.
We could attach the top with these 1x1 cleats along the front by driving a screw up from underneath. That would prevent us from damaging the scenery or the track work if we wanted to move it later. For a small layout like this, though, we could just put some screws down from the top. And we're using 1/2-inch plywood because 1/4-inch plywood is too thin and 3/4-inch plywood is too thick. There are other ways of using L-girder construction than a solid plywood top. This model shows the riser method of track mounting. The plywood is cut into pieces to support the track so the scenery can easily go above or below the track. It's especially good for track with a grade or a rise. That's because it gives smooth transitions between high and low points. It avoids sharp changes in grade and track kinks. For an around-the-wall layout, we could use brackets like these, which attach to the wall and have L-girders here and here. Here's a more elaborate layout showing the versatility of L-girder construction. If you need a peninsula extension, just add legs and additional girders. If the scenery drops down, just drop the L-girders down. You can make silhouette outlines of the scenery and let them support the track instead of risers. Finally, the frame can be extended to support a backdrop to hide corners and create a sense of distance. Alan, even for a very complicated layout, L-girder construction, as explained in this Kalmbach book, makes benchwork easy. For our little layout, we need 2 sets of legs, 1 L-girder, a second L-girder, 1 cross brace, a second cross brace, the middle joist, and the plywood top. Now I've got this track plan, and we've got the track, but I could sure use 6 turnouts over here and maybe a double slip switch.
Remember, Wayne, keep it simple.
Track is one of the most important elements to keep your trains rolling. If you lay it right in the first place, you're guaranteed hours of carefree operation. But if you're careless, you'll have all kinds of problems, including derailments. Commercial track comes in many forms. This is snap track. It comes in curved 15, 18, and 22-inch radius, both in brass and nickel silver. Flex track comes in many gauges. This is N scale. Little rail joiners will conduct the electricity. Plastic rail joiners act as insulators. For the ultimate, some modelers scratch build their track. They use individual wood ties, purchase rail, and with tiny little spikes, actually spike the rail in place. Now let's join two pieces of track and see what happens. You want to have the track in the rail joiners, not like this. Otherwise, this may happen. No matter what kind of plan you have, it's best to lay it out full size like this, either on a sheet of paper or directly on the plywood top. Even the best drawn plans will need adjustments, especially around the turnouts. It's best to start at the turnout and work away from them. For example, in this layout, we wanted to put this bridge next to this turnout. If we had, there wouldn't be enough clearance for the locomotive. What we'll need to do is add a short section of track. I'm going to cut a piece with the motor tool and an abrasive disc. We'll need to trim off part of the ties. Be sure that you're wearing safety glasses when you're doing this. Finish it with a file to square up the ends, and we're ready to put it in place. I suggest that you temporarily assemble the entire layout to be sure everything fits as planned. Let's have some fun and see if the locomotive will run. This also tells us if we have any problems. Once we're satisfied that a train will run, we need to go back and check the alignment of the entire layout. Make sure that each rail joint is tight and that there are no kinks in the rail, especially in the curves. I use small wire nails to temporarily hold the track in place as I work around the layout. Don't be afraid to reposition and realign the track until everything is perfect.
What's next, Wayne?
When you're satisfied with the track alignment, take a pencil or a marking pen and mark the center line of all the track. Also, mark any areas that we're going to cut out later, like a lake or the river here. Take out the temporary nails and remove all the track. With the saber saw, cut out the sections of plywood we've just marked for removal. Make sure you wear safety goggles to protect your eyes from sawdust and flying wood chips. It may be necessary to move one of the joists, for example, this one in the middle of our lake. Simply unscrew the joist, move it over, and screw it back into the L girder. Now we start laying the cork roadbed. It comes in strips like this that we tear apart and reassemble like this to form the basic roadbed contour. Each half piece of cork is nailed in place with half-inch brads and follows the center line that we marked before to form the roadbed. Some modelers use both glue and nails. When working with turnouts, tack down the outside pieces first, then fill with cut pieces, or you could use scrap. Also cut a piece of cork for the switch machine. Stagger the ends of the cork wherever possible. Sand the cork flat with medium grit sandpaper. This way you can easily pick out nail heads that are too high and also remove the unnatural lip at the edge of the cork. Vacuum up any debris. Next, we return the track pieces to the layout. Check your track plan for the location of insulating rail joiners. We'll discuss that in more detail later, but you'll need to have them in place now. For this layout, we'll need insulated rail joiners here here, there, here, and here. Alan, if you forget to put the insulated joiners in, you can always take a motor tool and cut insulating gaps in later on. When the track is in its final position and there are no gaps or kinks, start tacking it down. Use a nail set so you don't damage the track with the hammer. And make sure you don't drive the nails in so far that they cause the track to buckle. Sight down the track and watch for kinks. Use the nail set set at an angle to adjust the track. When you're satisfied, take a broad, flat file and file each joint until it's perfectly smooth. With a jeweler's file, file the switch points so that they blend smoothly with the stock rail. This will prevent wheels from picking the points as they enter the turnout. Take a National Model Railroad Association track gauge and use it to check that all your track is in gauge, including the turnouts. If the track is too wide or too narrow, it can be fixed by putting a soldering iron on the rail, not the ties. This heats up the rail and causes the ties to get a little soft. Now, put in your NMRA gauge, remove the soldering iron, and let the track cool. Then take out the gauge and recheck the track. You could also use small spikes to adjust the track. When the track is done, it's a good idea to run a magnet all along the track to pick up any nails or spikes. This will keep them out of the locomotive's motor. Next comes the wiring.
Keep it simple.
The operation of a model locomotive is really quite simple. If the direct current is supplied to the rails, positive here, negative there, the locomotive moves forward. If we reverse, positive here, negative there, the locomotive moves away. This action is normally handled by the power pack reversing switch. Now let's look at our track plan. Power can be sent to the rails from almost any point, such as here. We can use a terminal track with two simple screw connections. This will energize all the track, and we can operate a locomotive at any location. After a while, you may want to run more than one locomotive. That means getting power to each locomotive separately. One way of doing this is to divide the layout into electrically isolated blocks by inserting the little plastic rail joiners into the tracks. I broke the layout into 4 isolated blocks. A train can be held in this siding or this one by shutting off the power to these blocks. A second train can operate in the remaining loop. All we have to do is apply power where we want the trains to run and cut off the power where we want the trains to stop. Using these two and then these 2 blocks, 2 separate trains can switch the 2 sidings at the same time. More sophisticated track plans would, of course, have many more blocks. As we laid the track, the layout was divided into 4 blocks. To route power to each of these blocks, we need 2 electrical leads for each block. They could be connected to a terminal section, or the leads can be soldered directly to the rails. Drill a 1/8 inch hole next to the rail and feed a wire through. Strip the end and bend it twice, like this. Using a file, clean the outside edge of the rail. Move the wire into place. Add a touch of rosin flux and rosin core solder with a hot soldering iron. Try not to hold the iron in place too long, or it could melt the ties. If there's a problem, lay wet cotton balls on either side of the iron. This will cool the rail and keep the ties from melting. If done properly, the connection is almost invisible. We'll consistently use a black wire for the inside rail and a red wire for the outside rail. To keep our wiring organized, I've labeled each wire. This makes troubleshooting much simpler. All the wires pass through eye hooks on their way to the control panel. At the control panel, the wires end in terminal strips. This makes the wiring much easier and neater to service. If you're like me and don't like to solder, you can use a solderless lug like this. Simply cut the wire short, put the lug in place, use the crimping tool. It's just that easy.
Wayne, how can we run 2 trains?
Well, you need 2 power packs, or at least 2 control units. This is called dual cab control. We need an electrical device that lets us connect either power pack to every block. This old knife switch takes 2 leads from either pack and sends them out this way to the block. This is a DP-DT, double pole, double throw switch. Of course, the knife switch is much too large, so a sub-miniature DP-DT toggle switch or a DP-DT slide switch should be used. If you don't like soldering, a larger DP-DT switch with screw connectors can be substituted. The 2 wires here on the center terminals go to 1 block. The terminals on the sides connect to the power packs. Make sure you get center-off DP-DT switches. The front of the control panel is made of 1/8 inch masonite. The track plan from striping tape. Holes were drilled in the masonite so the switches mount directly through it. The inside of the panel shows how each block is attached to both power packs. I've used red and black wire for the left pack, orange and green for the right. Now a flick of a switch can connect each of the blocks to either pack. The power packs and the panel are mounted on a simple wood platform attached to the benchwork. The final bit of wiring is for the turnouts. You can follow the manufacturer's suggestion and use these controllers with 3 wires to the switch machine. This button controls the position of the turnout points. With a short push, the turnout snaps from one position to the other. The controllers are quite large, and with a complicated layout would take up too much room on the panel. An alternative is to use a single pole, single throw push button on the panel to control power to each side of the switch machine. Power from the AC terminal on your power pack passes through the SP-ST button and activates the switch machine. If all this electrical stuff is too much for you, manual throw turnouts are just as good on a small layout. Well, it's been a lot of work, but the Marengo Milwaukee and Northern is ready to come to life.
Well, Wayne, now that the wiring and track layering are done, what's next?
Well, now it's time to add some flavor and character to our layout. Let's begin working on the scenery. You know, one of the nice things about model railroading is you don't have to be a professional artist to have realistic scenery. Also, scenery is an important element that sets the tone and really the theme and the rationale for your entire layout. Perhaps Colorado narrow gauge appeals to you. Malcolm Furlow's San Juan Central can serve as an inspiration. Or maybe the rolling Appalachians are for you. Alan McClellan's Virginian and Ohio captures the feeling of a coal-hauling railroad that fights the grades. The scenery which sets the theme includes the geological elements and the structures. Each of us has his own thoughts on how the elements might go together, but I would offer 2 rules. 1, no terrain is perfectly flat. The prairies of Illinois have little streams that dip down from the tracks, and small hills rise up here and there. Taking a piece of plywood and just slapping the track down on it will not be realistic. 2, don't use any building or car straight out of the box. Dull the colors. Tone it down with muted and flat colors. Dirt, dust, and the aging process of the sun make most real objects rather flat, not shiny. More information on weathering and scenery is available in 2 Kalmbach video cassettes, Building Model Railroad Scenery with the Experts and Weathering Railroad Models with Malcolm Furlow. Also, this book, How to Build Realistic Model Railroad Scenery, should be in your library. Now let's get to work on the mountains, or rather should we say in our Midwest theme, the hills. You know, modelers have used many different methods to build models of mountains. Some modelers have used screen wire and plaster. Others wadded up newspapers covered with towels soaked in plaster. Still others have used broken ceiling tiles and even surgical gauze impregnated with plaster. For our small hills, probably the easiest is sheet polyfoam. It's very light and easy to cut and shape. Our plan is to have a set of hills here to hide the control panel and allow for a little cut to run the trains through. This eliminates the impression of running around in a circle all the time. Our town should not be on a single level, so we've laid down sheets of polyfoam here to give it a little contour. Finally, a small lake will occupy this site and drain out under the tracks where it joins a little drainage ditch. Come on, Alan, let's get cutting.
What is this stuff anyway?
Polyfoam material is used for insulation. It comes in two forms.
One is like this. Actually little globs of plastic fused into a board. It's sometimes called beaded polyboard. A second is like this. A lot of tiny little hollow cells. This is called extruded polyfoam. Depending on the application, both can be used for scenery.
The extruded type is best for smooth scenery, rolling hills, deserts, stepped bases for cities and villages. The beaded board tends to tear and break out in chunks, so it's fine for rough terrain, broken rocks, and such. How we coming, Alan?
Well, I've roughed out the corner here with 4 pieces of beaded board. Now with some water-soluble contact cement, they can all be glued and piled together.
Great. With a knife and a large blade screwdriver, we'll rough it up a bit, like this. Gouge here and a rip there. We'll give this scenery some character. We need a little river here. Can't be afraid to tear this stuff up. All right, here we'll put some striations, straight lines across. May look ugly now, but it'll look a lot better later on. This is where you need the shop vac, too. Ah, that's getting there. Now it's time to add some color. I went down to the hardware store and got some cheap paint. You know, the kind of thing on sale, a second, a return. Well, this has to be latex paint now, too. We'll need a brown, an off-color brown, though, an earth brown, not a dark brown. We'll also need a green. Now, the green should be off-color as well. Avocado, khaki sort of color. My boys call this yuck green. The greens go up on the top in the areas where the vegetation might grow, while the browns go into the open spaces where we might see, like the stream here or the open face of the rock. You really don't have to be especially careful, because whatever mistakes we make, we'll paint over it anyway. Now, we might want to add a dash of a bright color, say a red or a yellow. We can put a yellow in here. That could be a mineral or a rock deposit. If it's too bright, we'll paint over it, color over it anyway. When we're finished, though, we want to cover all the white. Before the paint dries, we want to add some form of ground cover to give our surface some texture. I'll be using both sand and light earth. Let's put the sand right down here where the open earth is exposed. Now, a little of the light dirt will add some contrast. A few rocks or two don't hurt. We'll be using Woodland Scenic's burnt grass for the green areas. Again, we'd like to vary the color, so let a little of the avocado show through. And some coarse turf will add a three-dimensional effect. Finally, to highlight the texture of the rocks, we need to spray the open faces with a black stain. I use a concoction called Doc Wezzo's Wonder Weathering Goop that's a mixture of black leather dye, not shoe polish, with rubbing alcohol. The proportion isn't important, just a little bit of stain to a lot of alcohol. What we want to do is darken the surface here. Other people use black India ink mixed with water, old thinner, or thin black paint. A few bits of lichen or commercial trees will give us a bit of vegetation. To set everything in place, we first wet down the entire area with water and a few drops of liquid dishwashing detergent. Then we soak the area with a mixture of 1 part matte medium and 5 parts water. Matte medium is available at artist supply stores. After drying overnight, our little hill looks like this. The corners are blended into place with the same materials and scenery techniques I just showed you.
Wayne, this plastic track doesn't look very realistic. What can we do to improve it?
Well, unfortunately, plastic track looks like plastic track. The first thing we should do is to improve the color. With a can of Pactra Dark Earth spray, we can give them a nice wood tone. Also, the rails can be sprayed a rust or a grimy black color, but you need to come in at a much lower angle. Use a piece of cardboard like this to protect the ties from the black color. Now let the paint dry. Finally, we need some ballast, the stone that holds the track in place, yet allows it some degree of motion. Ballast comes in several different colors and sizes. Get the right size and color for your scale and scenery. We're using John's Lab HO gray ballast. You might want to try to vary things a little with the high iron main line well manicured and the yards weed grown, but almost no ballast showing. I used a spoon to apply the ballast and moved it in place with my fingers to the contour we finally want. In the yard, the ballast spreads out more and blends together with the dirt. With the ballast in place, use water with the detergent again. Then, with an eyedropper or an old glue bottle, apply the matte medium and water mixture. This dries overnight and bonds the ballast to the track, yet the track stays somewhat flexible. Be very careful around the turnout point so you don't get ballast and matte medium into the moving parts. When we're all finished, use a Bright Boy or similar eraser to remove the matte medium from the top and inside top edge of the rail. If you don't do that, the matte medium will insulate the rail from the locomotive.
You said we would have a lake and some ditches. How are you going to do that?
There have been many different attempts to model water, probably going back to the very first model railroads. Real water isn't very good. It tends to leak out, it corrodes locomotives, and in small quantities, it just doesn't look like water. Water is colorless, so the colors that we do see are the result of reflected and refracted light from the sky and from the shoreline. Recently, two methods seem to be the norm for making water. One is to use a two-part casting resin, such as this Castilite. When the resin and the catalyst are mixed in the right proportion and poured into the stream bed, they solidify into a clear water-looking plastic. Pours must be limited to about 1/4 inch or less as the material heats while it's setting and can crack if it overheats. One disadvantage is the resin as it dries tend to creep up the edge of the bank. Also, the chemicals have a very strong odor. It's a good idea to have the family away for the weekend when you pour this stuff. A much newer approach is to use Artis Gloss Medium. See, it's a thick white gel that can be dyed or tinted with acrylic paint. It has no strong odor, cleans up with water, dries clear. Let's do our lake with this stuff. The base is masonite or plywood and the scenery is finished as before. Cover the base with a flat black and use a tan that's feathered into the black. The combination of the black and tan give the illusion of depth. When that's dry, add some sand or a sandbar type effect. Fix it with the matte medium that we used before. The gloss medium mixed with a little black is added to the middle here. Again, the black gives the illusion of depth. When that's dry, we add more gloss medium on the side to blend the sandbar into the middle. Finally, gloss medium mixed with blue or green is added in several layers until we complete our lake.
That doesn't look much like a lake to me.
Be patient. As the gloss medium dries, it becomes crystal clear. See, this lake has had time to dry now. If you want to add more, just go ahead. Long swirls give the impression of gentle swells. For a rapids effect, you need to stipple the surface a little and add a little white around the rocks. A final coat of clear gloss medium will give the surface that slight reflective coating of real water. Now, how's that for a lake?
Much better.
The water in this outfall is gloss medium dried on a piece of glass, then hung on the pipe and painted in place with more gloss medium. The final scenery element is my very favorite, the structures. You can change the theme, period, and focus of your layout by just adding or changing structures. Almost every structure on this layout is a plastic kit that took only a few hours to build. First, we need to flatten and tone down a building like this. I like to use polyester grime, rust, just something to change the tone of the building a little bit. I want to take down that gloss. For areas like this that are very dark, we need to bring some highlights in. We use just a little bit of white and we'll scrub it on. This technique is called dry brushing. For bricks, I like to use first a dulling wash, like the black dye that we used before, to tone down the bricks. Then we can add powdered tempera or chalk to highlight the mortar lines. I want to take that off with a moist finger. And then add a little chalk here or there to bring out more of the mortar lines. See how easy? To fix your weathering, simply spray dull coat on it. The station here is not a plastic kit, but a wooden Campbell kit that I built in another Kalmbach videotape, building model railroad wood structures. I think the station really makes a special scene on the Marengo, Milwaukee, and Northern. An optional piece of trim is this fascia board that gives the layout a finished look. It's made of masonite, and it could be painted. Don't forget to add all the little details like people, cars, and bits of junk here and there. These little details do make a big difference. Our little layout really has a life of its own now. I'm ready to show you how to keep the trains rolling. Once the layout is finished, operating can be a lot of fun, unless you've got uncouplings and derailments.
What are the main problems and how can we avoid them?
No matter what scale, most of the trouble comes from three areas: couplers, track, and trucks. The real key is to do things right the first time and keep them that way. One car with excellent couplers is much better than a dozen that are a constant headache. As on the prototype, the purpose of the coupler is to easily connect and disconnect the cars. They have to operate successfully over and over. Most easy-to-build cars come with horn hook couplers like this. They couple with a sideways action and can be uncoupled by inserting a small screwdriver and turning it, or by passing the car over an uncoupling ramp. They're inexpensive, but don't look anything like a real coupler. Another type that's more prototypical and works better is made by Kadee. They can be purchased as replacements for horn hook couplers. The Kadee has an operating knuckle that is activated by a small pin, which in turn can be moved by a magnetic uncoupling ramp. Although it's a big job, almost every advanced modeler eventually converts to Kadees. But this can be done in easy stages if you mount a Kadee on one end of a car and a horn hook on the other. This car is a transition car that lets you use both types of couplers. Let's talk about the elements of couplers that are common to all types. One is that they've got to move absolutely freely. This means taking the time to be sure each coupler pocket is free of burrs or rough spots. See, this car has a coupler that isn't pushing off to the side as a hook horn should. Well, if we take the cover off, we see there's a little burr on the top of the pocket. A small file will remove it. Now it's time to check for other rough spots and file them down as well. Maybe here on the shank, and especially where the tension spring is. Satisfied that everything is smooth, a little puff of powdered graphite will keep things moving freely. Don't use oil. It picks up dust and turns everything into a gummy mess. See how nicely the coupler moves now? A Kadee should be free to move from side to side and return to the center. Once you're satisfied that the coupler is free and easy to move, we should make sure that the coupler is centered on the car. If they're out of line, they'll separate on curves and hills. Be sure the pocket is in the dead center of the car. Two couplers will not couple if they are not on the same center line. Move the pocket. The height must be correct, not just close. This is best done by using a Kadee coupler height gauge. This car's coupler is too low. To solve the problem, we lift the entire car by adding these little washers between the truck and the car bolster. Replace the truck and check it again. If the coupler is too high, we could either remove some of the material from the car bolster, or if the coupler pocket is removable, we could place a shim between it and the car body. Either method will lower the coupler, but be careful. If you file off too much of the bolster, the wheels may hit the car underbody. With Kadee couplers, the uncoupling is performed by a magnet. It pulls the two pins to either side and opens the coupler knuckles. If the pin is too low, it may snag on the tracks and cause an unexplained derailment. Raise it by squeezing the pin in a pair of pliers like this. Then check the car on the gauge again. If the pin is too high, it may be too far from the magnet to properly uncouple. Lower the pin this way with the pliers. Not like this, or it will distort and may break off. Use a gentle squeeze. Following these guidelines, all your cars and locomotives should give you trouble-free operation. Trucks and track are the next areas of maintenance. Our best friend in correcting track and wheel problems is the National Model Railroad Association gauge, which is available in several scales. Cut into this piece of sheet metal are all the critical dimensions a modeler needs. It is used like this to check the gauge of wheels on an axle. The flanges should fit comfortably into the notches. If the wheels are out of gauge, press them into gauge and add just a drop of super glue on the inside of the wheel at the axle. Wheels that are out of gauge will not stay on the track. Be careful that the wheels are centered on each truck, or you may wind up with a dogleg truck like this. It will force the truck into the rail and cause derailments. All four wheels should touch the track all the time, not like this truck. This can be caused by tightening the screws too much on the side frames, as on this truck, or the plastic side frames may be warped. The warp can be corrected by putting the plastic side frame in hot water and pressing the truck against a flat surface until it's straight again. In the final analysis, the wheels must be free to turn in the trucks, and the trucks must be free to rock slightly under the car. If the car tends to wobble too much, tighten one truck, but leave the other free to absorb the motion. When we laid the track, we checked to see that things were positioned properly. If there is a location where derailments persist, it's a good idea to check that location again. Use this end of the NMRA gauge to check the track. The fit should be snug, but not tight. These points are used to check the clearance in the guardrails of a turnout, and the general size of the gauge checks the clearance around and above the track. It's a handy tool to have. If you find a rough spot, file it until it's smooth and everything runs perfectly. If you can't fix the track, don't feel bad about replacing a piece. The real railroads do it all the time. Of course, you know that no matter how perfectly things are done, the one time a derailment occurs is when you have a visitor watching. Well, let's look at the most important element of any train, the locomotive. You know, our model locomotives are very reliable if properly maintained. Most basic engines disassemble very easily. Steam locomotives may have a screw or two either through the dome here or on the underbody, like here and here. Diesels usually have a body shell that is pried away from the chassis. First one side and then the other. If we place the locomotive back on the track, we can see the major parts. Power is drawn from one rail, sent up to this movable coupling, then over to the motor, through the commutator, and then power returns to the track through the frame. Reversing the flow reverses the direction of the locomotive. Some modelers remove these metal clips and replace them with a piece of flexible wire. That certainly removes the possibility of breaking contact at these moving joints. Typical servicing includes polishing the contact surfaces and wheels to remove any oxidation or dirt. A small screwdriver with a rag wrapped around it that's been sprayed with TV tuner contact cleaner can be used. Lubricate the motor bearings here and here with just a drop of light oil designed for model trains. Use an oil that does not harm the plastic parts. Also put a drop on the gears and gear bearings. After a good cleaning and lubricating, you should see a real measure of improvement in the noise level and performance of your locomotives. Hey, this is really fun. You know, we could do some switching over there, or maybe bring in a crack express train. But you know what, Alan? I think I need some help. Hey, anybody want to help?
Sure, Dad, it's our turn.
At last.
Okay, guys, you take over. You know, one of the great things about model railroading is that the fun really needn't stop here. There's so many facets to the hobby, it just goes on. And the layout is never really finished. And you don't just add more scenery and track. Probably the next thing to think about is operation. This Kalmbach book by Bruce Chubb gives us all the details. It explains how a model railroad can follow the operating features of a real railroad, scheduling, moving freight and passengers to predetermined locations. To improve operation, we could replace our stationary throttles with walk-around throttles. That way, each engineer could follow his train. With a bigger layout, command control could be added. This allows you to run up to 20 trains without a lot of complicated wiring. Radio waves traveling through the rails control each locomotive independently of the others. Or maybe you're interested in computers. Model railroaders use computers to generate switch lists, keep track of cars, and even control the signals. Beyond operation, there are other facets of the hobby. Craftsman kits. They take longer than simple kits we used on our layout, but they are oh so nice and satisfying. Scratch building. That's where you can build one-of-a-kind models of rolling stock, locomotives, and structures. This takes more skill than the Craftsman kits, but you have a model that no one else has.
Wayne, where did you get this car?
There aren't too many of those, Alan. It's done with decal work I did for the Marengo, Milwaukee, and Northern, using parts of a Milwaukee Road, Great Northern, and Alphabet decal sets. There's really more we could do for this layout. You know, I bet my dad must have built 10 layouts, and I don't know how many this is for me. Maybe we could add a peninsula, get a brass engine, buy some extra kits.
Dad, come on, get up.
You promised we'd start working on the new layout today.
You know, that's right, fellas. That's a good idea. I have been delaying too long. It won't be that hard, and we'll have a lot of fun.
For more help with the basics of model railroading, be sure to read these useful books: The ABCs of Model Railroading, H.O. Primer, How to Build Model Railroad Benchwork, How to Wire Your Model Railroad, N-Scale Primer, 101 Track Plans for Model Railroaders, How to Build Realistic Model Railroad Scenery, and don't miss the latest issue of Model Railroader magazine. It's your guide to model railroading fun. Visit your favorite hobby shop today and ask for Model Railroader, Kalmbach How to Do It books, and Model Railroader video cassettes.